Today my topic is the merchant circle. So when the excess material are removed from the outer peripheral of the workpiece with the help of a single point cutting tool, the workpiece is firmly tight on a 3-jaw chuck, 4-jaw chuck of a lathe machine. When the workpiece is moved in an anti-clockwise direction, the tool is fed against the rotating the axis of the rotating axis of the workpiece. To remove the metal in the form of the chips. In this process, the two coordinates are used x and y. So on the in this second number is orthogonal cutting process, in which the tool is fed at the inclined with the axis of the rotating workpiece. When the workpiece is rotated in the anticlockwise direction to remove the metal in the form of the chips at the inclination, in which process the three coordinates are used x, y, and z. Three coordinates are used. The cutting process are generally two types: the oblique cutting process. A second number is orthogonal cutting process, in which two coordinates are used. In this process, three coordinates are used. Before draw the merchant circle, so some assumptions are taking. These are the some assumptions. Number one is the edge of the cutting tool should be the sharp. The edge of cutting tool will be the sharp. Number two, the friction. The friction depends upon the shearing angle phi. Number three is the material should be the perfectly ductile, perfectly plasticity. So perfectly plasticity means when the tool is moved in this direction, the workpiece, the chips is moved. The material is moved along this surface of the workpiece. The tool to the continuous in the process. Due to the perfect plasticity. So the material should be the perfect plastic. Number three, the uncut material is constant. The thickness of the uncut material should be the constant. T1. T1 is the uncut thickness of the material. The orthogonal cutting process. In which process why is needed of the merchant circle? The merchant circle are generally used for to analyze the different type of the forces. During the cutting process, when the tool is fed against the anti-clockwise direction, so some force is also exert opposite direction. The opposite direction, those force are called this is the thrust force. This some force is other force is also acting on a cutting tool, that is called angular force. Due to the angular force, the vibration are created in a workpiece, and the angular force are play a very important role to controlling the finishing on the workpiece. This is the orthogonal cutting process are considered in this process. From this number is figure, this is the cutting force, this is thrust force, this is the resultant force, this is the uncut material, this is the T1 is uncut material. So sin B minus alpha is equal to Ft upon R. So Ft is equal to R into sin B minus alpha. This is the number 1. From this figure number you can also calculate the Fc. So Fc is equal to R into cos B minus alpha. This is the number 2. From the figure number 2, you can calculate the Ns. Sin phi plus B minus alpha is equal to Ns upon R. So Ns is equal to R into sin phi plus B minus alpha. This is the Ns. Same thing is Fs. So Fs means is equal to r into cos phi plus b minus alpha. This is the Fs. Question number, this is the 1, 2, 3 and 4. Yeah? Equation number 1, equation number 2, equation number 3, equation number 4. From the equation number 3, the sign b is equal to f upon r. The f is equal to r into sin b. R is equal to sin b. Equation number 5. Same is apply here. The n is equal to r into cos b. Equation number, this is equation number 6. From the equation number 6. From the equation number 3, Fs is equal to r into cos phi plus b minus r. So here cos a plus cos b. Apply the formula cos a cos b minus sin a sin b. Put the value of a here in this. R is equal to cos phi into cos b minus alpha minus sin phi into sin b minus alpha. So r into cos b minus alpha into cos phi, r into sin b minus alpha into sin phi. So r cos b minus alpha here is, to put the value of here, so fc into cos phi minus r sin b minus alpha ft into sin phi. This is the value of Fs. This is the value of Fs. This is the equation number 7. Same is apply here. From the equation number 4, ns, here ns r sin alpha plus b minus alpha. So here the sin a plus b, to put the value here, sin a cos b plus cos a sin b. To put the value of here, r sin b into cos b, here cos a into sin b minus alpha. So r cos b minus alpha, here sin phi plus cos phi sin b minus alpha. To put the value of here, so f, this is the value of say ns, the value of ns, r cos b minus alpha fc into sin phi plus r sin b ft cos b. This is the value of n. Equation number 8. This is the value of here. You can find out the value of here. from the equation number 5, f is equal to r into sin b. So you can write here r into sin alpha plus b minus alpha. So r into sin a plus b. So you can r into sin a cos b cos a sin b. This is the formula r used. Same is apply here. F is equal to r into sin alpha into cos b minus alpha plus r cos alpha into sin b minus alpha. This is the value of here. So f is equal to r cos b minus alpha. R cos by is the fc. fc into sin alpha plus r sin ft cos alpha. This is the value of n. This is the value of f. So this equation is this is the 9. This is the value of 9. From the value of n, from the equation number 6, so n is equal to r into cos b. Equation number, from the equation number 6, n is equal to r into cos b. So here you can write in this way, cos alpha plus b minus alpha. So r is equal to cos a plus cos b. So you can write in here, in this, write cos a cos b minus sin a sin b. R into cos a alpha cos b minus alpha sin alpha into sin b minus alpha. To put the value of here, r cos minus b, r cos minus b fc. Here is fc cos alpha minus r sin b minus this ft sin alpha. This is the value of n. This is the value of n. The equation number is 10. Equation number is 10. So equation number is 10. Here, so you can write it here again. Mu is equal to tan b is equal to mu is equal to tan b upon b, beta is equal to f upon n. The mu means the coefficient of friction between the below the material and the cutting tool. This is the, here is coefficient of friction. The coefficient of friction is equal to tan beta is equal to f upon n. This is the friction, this is normal to reaction force. This is the value of f, fc sin alpha plus ft cos alpha divided by n. The value of n is here, fc cos alpha minus ft sin alpha. To divide by cos alpha is equal to fc tan alpha plus 1 divided by fc minus tan alpha. fc divided by the cos, this is cos is here, this is fc. So you can write is here the FC tan divided by FT. So FT plus FC tan alpha divided by FC minus FT tan alpha. So you can write here in this way. The FT plus FT plus FC tan alpha, and so you can write it here. So FT divided by cos to FC minus FT right in this way. You can write the value of phi, the value of mu, calculate by this formula. From this equation you can find the 11 number. You can write the 11 number. From this line you can see this. The T1 is the uncut material, or T2 is the thickness of the chips. So R is equal to T1 upon T2. The R is the chip reduction coefficient. R is equal to chip thickness ratio. R is equal to chip thickness ratio T1 upon T2. So T2 always greater than T1. The ratio of R T1 upon T2 is less than the unity. The value T1 upon T2 is less than the unity. This is the unity. Same is here. You can see that this is the width of these chips. This is the thickness of the chips. This is thickness of the chips after removing the metal. So same thing you can write when the force is applied here from this point. Chips is started. One line is drawn, passes through the C and D. This is the shearing plane. Like this. This is the shearing plane. This is the angle, shearing angle. This point is C, and this is point also D. This is the thickness. This is the thickness of the chips T1. This thickness of the chips is T1. So down is here in this way, like this. This is the width of the chips. The sine phi is equal to T1 upon CD. T1 upon CD. CD means you can CD is equal to T1 upon sine phi into B. Sine into phi into B. CD is equal to T1 upon sine phi into B. B is the shearing force. B is the shearing area. C is the shearing area. So you can calculate this shearing plane. From the if the angle, the mean shearing plane is tau. Tau is equal to FC. Tau is equal to Fs divided by the Fs. They divide by the CD into B. This is the Fs. Fs means shearing force. This is the shearing force. Where you are shearing force into this is divided by this area CD, and this is the B. B is the width of the thread. So Fs, the value of Fs divided by the value of Fs. The value of Fs, you can put the value of Fs. Here is F. This is the Fs. R is equal R into cos B plus B minus alpha divided by CD into T1 into B. This is the formula R used the meaning shearing plane. This is the shearing plane. You can find this formula used. If the angle of this is the rack angle. This is the rack angle. If the rack angle is 0, like this, this is the cutting force, this is the thrust force, friction force, normal to friction, This is the resultant force. This angle is 90 degree. Angle is equal to alpha. The rack angle is alpha. Rack angle is alpha. This is the merchant circle. So in this case, the cutting force is equal to the normal force. So thrust force is equal to friction force. In this case of when the alpha is equal to 0. So if the minimum energy principle are used, then the 5 are used to 45 degree plus alpha by 2 minus beta by 2. This formula are also used in the minimum energy principle. This formula are also used. So the merchant circle are used to analyze the different type of the forces those are acting at this point during the when the tool is cutting the material. So I hope that you will understand my lecture. Thank you very much to see my lecture. Thank you very much.